ladies and gentlemen. In the last videos, we have seen about parallel adders. So in a parallel adder, say suppose I have a 4-bit parallel adder. I have got four parallel adders. They work almost in parallel, except for the carry propagation delay. The operations are parallel. So that is, you apply four sets of bits to each parallel adder and perform the operation. These are combination circuits that respond very fast. Now there is another kind of adder, that's a serial adder, in which you use only one full adder block, and these bits are applied to the serial adder in a sequential manner. So that's a kind of a sequential circuit. So let me start with that presentation. So this is a short speech with, we will start with your learning outcome, the serial adder, and summary of your understanding. So what you will learn in this, there is only one outcome here. You will appreciate a serial adder. We will not go into detailed implementation or anything. So a serial adder is a sequential circuit with the schematic shown here. So what happens here is there is only one full adder in this. Say suppose in the case of a parallel adder, if I have got 4 bits to add, I have four full adders. Each full adder acts in almost in parallel, except for the carry propagation delay. They act in parallel, resulting in a very fast operation. But here there is only one full adder here. What happens here is these bits A and B, the numbers A and B are applied through registers. We will discuss about registers when we discuss the sequential circuits. But since it is included in the syllabus in this module, I tell you this. So a register is a kind of a storage device from which these bits are pushed into this full adder. So the bits are arranged in this manner in each register. The number B, that is B and minus 1 and minus 2, etc. B1, B0, and this is AN minus 1 to A1, A0. These are pushed into a register this way. Now at the first instant, this A0 and B0 are pushed into this full adder, and the C is a 0, so you get the sum value here, and a carry is generated, and the sum value is pushed into another register, a sum register. So this contains 3 registers, which are actually storage elements. 3 registers, two for A and B, and one for the sum. Okay, and then there is a delay element here, that is to delay this C out for 1 clock cycle. So at first this A0 and B0 are applied to A and B bits of the full adder. Its sum is computed here, S, and its C out is computed. So now this is applied to pushed into a register. Now this C out appears after 1 clock cycle, 1 delay here, so that at the next instant we will be adding A1 and B1, B1, A1, and this C0. So during that phase, in the next clock cycle or next time interval, what happens is it will be adding B1, A1, and C0. So that will then be pushed into this register. Then at the next instant, the carry may be generated. That comes here at the next clock cycle. Then I will be adding A1, A2, B2, and C1. Okay, so that result will be pushed into this register. So what happens is this somewhat a slow circuit, because you need some n clock cycles to perform this operation, but you need only one full adder. Okay, but however, the serial adder is not a very popular circuit. It is included in your syllabus. I tell you about that. Okay, so this is how a serial adder works. All these operations will be clear to you when we discuss the delay flip-flop and registers. We come to the summary. You appreciated the operation of a serial adder, and that is the end of this short video. I thank you all.